Hey everybody, thanks so much for stopping by. Today's video is going to be about steel quality, why that matters to us and why that matters to you. But first, as an introduction, I would like to talk about how these steel sheets are produced. This is just a gross overview. I'm going to skip some steps here just for simplicity, and I don't have a big visual effects budget, so I just drew everything out. So jumping right into it here, when the CPM steels or these on the Bowler Udahome side, their version of that are produced. First, what you end up with is an ingot that's produced by making a really refined steel powder and then heating that, packing it, and you end up with a bar ingot of a homogeneous alloy. So then as it's used to make sheets or other shapes for different industries, for our case, it's gonna be sheets because we cut knife blanks out of it and make it that way. So what happens is you have this larger ingot and you start cutting chunks off, and then through various steps you'll have your chunk that comes right off of your big bar, and that's going to be heated up, and then through several steps you're going to be heating that up and rolling it down to your final thickness. So along with that rolling, you're going to have irregular edges. So as part of the rolling, you're going to be trimming that excess off and eventually working down to your finished sheet that is going to ship to our facility. So through various steps here of heating, rolling, trimming, annealing, you arrive at the finished sheet from this ingot. Now from here, we take this sheet and begin cutting blanks out of it. And so we do a really good job here out of these sheets because they're very expensive materials. We nest very, very tight because we want to minimize the loss. We're paying for the scrap and the parts as part of the whole sheet. So it's advantageous to us to try and get the most efficient nest possible from each sheet of material. From there, we have rough parts. So these come out of the overall sheet, and then we grind the water jet tabs off and then work them over for preheat treat grinding and machining. From here to here, they are ground closer to a nominal size, and then they will be machined to their shape. So as part of this, we do the profile machining. We'll put the bolt holes in at all the little machine features. They're a little over nominal in thickness, so when they go to heat treating, they can be hardened, and then we still have an opportunity for straightening and following up with, once the parts are hardened, they grind better. The grit can't grind into the surface as far, so we want to leave an allowance for any straightening and finish grinding, and then we do bevel grinding, surface finishing, assembly, all those things. And eventually those knives then reach your house where you're happy and you get to go off and live your life and use a high quality knife. Part of this discussion today is from the manufacturing standpoint and why we're making some of the decisions we are, because a lot of what happens here determines what happens with us. And if there are allowable tolerances up here that are not advantageous to us, it starts affecting our plan down here. So I visually illustrated this. We've got roughly a bunch of rough parts here, but then through different inspection steps along the way, what I've been finding with some of these materials is that the amount of parts that I end up with at each step as I pick out things that are deficient, I'm left with less and less parts by the time we get here, and then we have less and less happy people. And that creates a lot of contention with you, with us, with our suppliers, and that whole thing is not constructive. So we have been working for years now to try and get better materials so that this process goes more smoothly, efficiently, and predictably, so that we have more happy people out using high quality knives in their day-to-day lives. So what I'm going to do now is just do some visual examples of some of the things that I've been seeing with materials. These are going to be CPM materials. As of yet, I've not seen anything like this from Bowler or Udahome, so I can't talk about that, and that's part of the decision to start pulling back from some of the crucible steels in favor of some of the Bowler and Udahome steels. The larger Bowler Udahome company has more resources and a larger think tank to make sure that these steps are a lot more tightly controlled so that I can better control my processes in-house. This isn't just about warped parts. There's sometimes some material deficiencies, and since I'm not a mass-produced manufacturer, I'm not part of that larger marketing money machine. I'm trying to do the best job possible for you guys and do that for a fair value, rather than having loss and things built into my business model, assuming that some of this is going to fail. I don't really agree with that. So I'm trying to get the most predictable, high quality things up here so that I can do my job efficiently and be able to sleep at night and stand behind the materials that I'm using to manufacture knives so that everyone is happy. That's always been my goal, is to have happy users. I like the positive feedback in the emails and on social media when people get their things. And that's why I got into this. It's been a learning journey, but it's also just been about making something of quality that I wasn't seeing for you guys out in the industry so that we have a different type of standard. And that's why I got into this, and that's why we're back in Pennsylvania now to drive all this home. So now I'm gonna put on my gloves and restart this video without this illustration, and we're gonna look at just a few of the things I've been seeing to better illustrate that, because I made another overview video and touched on this with the MagnaCut, and I only mentioned the warping, and there are other things that aren't just workflow issues on our end. There are things that could potentially affect the performance and consistency of the tools out in the world, and that's not acceptable to me. So let me throw some gloves on here and we're going to talk about it. Okay, so I'm realizing I'm going to have to shoot this in several steps here. These still have a little machine oil on them, and I'm going to look at some surface finish parts after this and talk about that as it relates to what I was seeing on these ground parts. And I want to white glove those with our cotton gloves. So we're going to start out here with rubber gloves, and then I'm going to throw some cotton gloves on for the next step. But these are all MagnaCut parts. I'm about to send these back to Niagara Specialty Metals, who will talk to Crucible Industries about what we're seeing here. So these were from the decarburization batch. And while we're talking about this, just remember the manufacturing methods. And just to me, a lot of this doesn't make sense, and I have questions, and I haven't really gotten clear answers on what this is. And I want to trust the materials. So we're talking about it, and I know there's other people out there with knowledge. So I'm hoping maybe we can just start a conversation and help get all this stuff dialed in and up to the standards that I know it can be at. Bowler Home, other companies, even a lot of these companies making high-end electroslag remelted grades are, I believe, achieving as good or better results than some of these CPM steels. So I'm just, in my opinion, there's some manufacturing or some process deficiencies that need to be looked at, and we can't start having that conversation unless we're transparent with information. So that's the purpose of this, and I just want to talk about this and see if we can come to some more productive conclusions here. So these were from the decarb batch, and these sheets were starting out as 207, 227, and these were the thinner 5.1s. I picked them out when I saw these things, but we are like 25 thousandths or so down into a rough sheet. So in my mind, how these materials are manufactured, this whole sheet should be homogeneous out of the center of that billet. After all the rolling and trimming, this should all be good homogeneous CPM steel that's relatively free of defects, and that's not what I'm seeing. So looking at this part, we had a weird void, and I'll post some other footage at the end of this to show how some of this presents on the surface grinder. We break into what looks like kind of a tinfoil layer, and then it breaks free and shows these little voids in here, which they're just really thin, long pockets of nothing down inside the material. And that causes me concern, just because I don't know where it's coming from, why it's happening, and how that might affect the durability of the tool. So I picked those out, especially in these high stress areas. When I see one of these, I'm finding that there could be some other small things in the neighborhood of that. And since I don't have X-ray inspection equipment to do an NDI inspection on these things, I just pull them out because I believe in what we're doing, and I don't want to set you up for failure or have you have a negative experience. So that's one of the things I was seeing. And then There's another one right here, just a slightly different style of void. So yeah, that's definitely a big chunk just not in the sheet where there should just be homogeneous material. Again, that's one of those thinner parts, so we are well into the middle of the sheet there. And this was another one that cropped up during that time. And for this to have this many instances in that few of sheets is another part of this that's alarming to me. The ratio is a lot higher than just a oops here and there. So that's another one of those. You can see we're starting to break back through it there. I think another 2-3 thou would have probably been through it, and that I wouldn't have seen it, but I did, so we're talking about it. And then this one, yeah, this made it quite a bit further. Mike over there on his machine had noticed this, and I just decided to grind it a little bit further and had a foily bit come off there, and now that's just a monstrous void there, right in the middle of the daggone sheet. Now, let me see if I can get that closer to that screen. There we go. So you can see I tumbled it a bit just so I could have a look at it, but we do have like some dark areas there. I don't know if that's just from the heat treat where it darkened and had like a little oxide pocket in there, and then we started to tumble it away. And then you can't really see it anymore, but there's just a little void right here as well. And I'll show you that same feature on another blade and then what happened once I started getting into surface finishing. I guarantee you there's a little pocket of nothing in there. It's not just that little stringy looking thing. And I've got evidence to suggest that there's something more akin to that hiding in there that we're just starting to break into. And again, that's the same thing there, just that, I mean, that is in the middle of the sheet of a 207-227 sheet, and it's down in the middle near the cutting edge. So there's no, in my mind, no reason to have voids or inclusions or anything down there. And I would suspect that these are the reasons sometimes we have failures and things failing in ways that I wouldn't expect or under less force than I would expect. And that's what I'm here to talk about, is when you see things like this and then what I'm going to show you next, I worry about just how the materials are going to respond in heat treat and how some of these things that I'm seeing are going to affect the durability standard, how it responds in heat treat, just things like that. And I am also, just my lead machinist pointed out, you know, when we start saying with some of these steels that they're knife industry specific, these are knife steels, that sort of alleviates the manufacturers from any of the tool and die standards. If you're saying they're knife specific, I'm not sure if that's going to set an even lower bar compared to the tool and die, where, you know, you do have some aerospace applications where some standard needs to be held, absolutely. Otherwise the materials are out of spec and go back to the manufacturer. So, you know, looking at that, I hope you guys can understand my intention here, why I'm starting to diversify some of our materials, so that if things like this happen, especially if it gets thrown back in my lap from the manufacturer, if this is an acceptable standard to either Crucible or Niagara, I've got to deal with this. And looking at what I have laying around here, I have about 6-7 pounds of loss directly. And then when you start looking at the thickness I ground away, the surrounding material, that gets into be, 10-11 pounds of direct loss. And then all of the lost time that we spent machining these parts, grinding them, the expense of heat treating them, transporting them around, bevel grinding them, everything that the time and effort and money we spent getting these this far, that ends up being wasted time. So in addition to the direct material loss, there's all of that wasted time, and that's time that we weren't making good parts. So that's where, beyond the loss, I'm not complaining about the work being hard. It's the predictability and just being able to trust the materials and being able to trust these materials with regard to the health of our business. I want the best for you guys, but I can't have it cost me a pound of flesh every run if the manufacturers aren't going to just like, oh shit, sorry about that, we'll make that right for you. If it's an argument or I got a waiting time, that's time my machines aren't doing stuff. So we have to start moving in a direction where we can have predictable production, and then if people want these US produced materials, we can offer them in a way that makes sense for everybody. You get what you want at a good value, we get what we need to keep our business moving, us investing in technologies, employees, improving our processes, expanding our runs, just everything that we all want, by working together and coming to some common understandings, everybody wins. So I'm hoping through just providing more thorough information on this, you guys can understand our position, some of the struggles we've had leading up to here, and then where we're going from here and why. So we've looked at these. Next, we're going to look at some of these issues in surface finish parts and how it relates to that. So stand by. Already, I see at this distance, you can see some of these striations across the surface, kind of like tiger stripes. It was hard to find a light, but that actually worked out pretty well across there. Just looking at some of those little differences where they almost look like the elongated rice grains across the surface. That's one of the things I've been seeing, and I've seen that in 3V before in the past, and that's what caused me a lot of warping. And it's really, really light there. But that caused me a lot of warping and some loss with some GSO 4.5s in the past. With the warping just didn't want to come out. It was a little more pronounced than this, the way it is here in the MagnaCut. But again, I don't know what that is. We've already ground about 14 thou a side off of each sheet. That's at least a solid 10 or 12 per side pre-heat treat, and then another 2 to 3 per side post-heat treat. So I know it's not heat treat related, but then as I put it on balance with some of these things that I'm seeing down in the sheet, I think that they're probably related. You can just see all those kind of elongated football shapes across there, and then it does go away as you get down into the bevel, and that's what I noticed with the 3V. It was a more pronounced because I think the sheets were thinner and they cooled faster during processing. But with how these materials are made, I don't know how that's happening, and I think that some of this, my prep process is a light compressive peen to normalize all my grinding and make it the same tone there so that we get a cleaner stone wash. But as a result, it's not angular like an AO finish, and it illustrates different densities across the surface. So in lieu of any more like transparent information, what I believe is probably going on here is we have slight variances in the density and possibly the composition of this material within the sheet, so that it's not all exactly homogeneous. And then this looked like one of those little lines. Mike had pointed it out to me, but then when I did surface finishing, all this blew out of here. So that was just waiting to come out of there with a little bit of pressure, and just revealed those giant voids down in the sheet. So obviously I'm not trying to let this out of the shop with or without a warranty, because I don't think that's operating in good faith to just say, that whatever, you can have it without a warranty. Because if I don't know what this is and I don't know what to expect, I'm transferring a lot of liability, and that's not good. If it's, if I'm Jim Bob working in my garage and I'm just making knives, that's one thing. But I have a company, I have employees, overhead, insurances, and I don't think that that's to anybody, that's a good faith effort of putting out something that I think is safe for use in this sort of application. So things like this I hold on to, especially with big voids like that. I've found that this, if it's mild, it doesn't really affect anything. I was still able to flatten it, but as it gets more and more pronounced, I start to worry about that and how those different densities are possible, different, I think that the concentrations of alloy are changing within the part, where I don't know if that's going to change the physical characteristics post heat treat and the overall durability and the performance characteristics. So I control what goes out of the shop very, very tightly, but if these very expensive materials are doing things like this, it makes it harder and harder to maintain good prices while being able to take the time to do the work correctly. You know, you have to swim faster and faster to get to the same place. And, you know, unfortunately in a capitalist system, I do have to produce profit and be able to pay people and operate within the confines of our economic structure. So I just, you know, those things give me pause. So now that Böhler Uddeholm is taking a closer look at the knife industry and bringing some of these third generation powder steels, I feel like I have less of a boot on my neck, and I can be more transparent about these things and talk more openly about it, knowing that I have some alternatives. And it's my hope that we can foster a more transparent attitude on this side of the pond and talk about some of these things so that they can be dialed in and we can all work collaboratively to get this stuff resolved so that we can push the industry in a better direction and you guys have the best tools possible and everybody wins. But yeah, so that was one of those, and it's on both sides to an extent. You can see more here. So it is on both sides, and I'm not sure how that's occurring. That's, I think, just a little bit of dirt or oil there from the rubber mat. But yeah, this wasn't quite clean. I should have cleaned this. I pulled the towel off, and I thought it was clean. But so this is one of the parts. Since that deficiency there is pretty big, I'm going to add this to the pile to send back to Niagara so that they can run this by Crucible for evaluation. But I did want to video it because I'm not sure if I'm ever going to see these parts again. So yeah, you can really see all those striations across the surface there. And what worries me is we are pretty deep into the daggone surface. We should be into absolutely homogeneous material, and that's not what I'm seeing along here. And then here's a lesser example of the same thing. This one, I'll let this out the shop. So this is smaller things that, like, this blew out. I watched it, just a little shimmery foil went away while I was surface prepping the blade. And again, that shouldn't happen. The purpose of a particle steel is to have a higher level of uniformity, something that's very homogeneous so that you can have a higher performance standard than a conventionally formed alloy. But when I'm looking at things like this, I think there's a lot of high quality ESR grades, like I said before, that are on par with this or better as far as the uniformity and grain refinement. All the physical characteristics of it are starting to surpass some of this Gen 1 CPM product, and that's not, to me, acceptable. So that's just a little thing there, and I think that was everything on this blade. The other, 1 second here. But again, you can see some of those little striations across the surface here, and it's a little more pronounced on this side. Yeah, just those little shapes. And if there's anybody with like a PhD metallurgy background and you know what this is, please just drop a comment or reach out to us, drop us an email. I'm happy to forward it to Crucible or Niagara. I don't know if they'd like that, but it's, we're here to learn stuff and to better ourselves and each other. And I'm here to provide you with what I hope is a valuable service and high quality tools. So that's what I'm going to keep doing. Like I said in a previous video, I don't make steel, I make knives. So I'm going to choose companies and materials that will stand behind our small business and, absolutely be a backstop against things like this. And right now, that's not what I'm seeing. And I'm disappointed, but we're pressing forward and finding other options like we always have. We just keep pressing forward. So real quick, I just did want to show here with all of this, with the higher level of things going on here, I had noticed, was it back here? I can't find it right now. There was one of these had something somewhere else, but it's irrelevant. We've got enough things going on here. But now, just in contrast, I've never seen this in a Böhler steel, and I just wanted to show you, I just also surface finished a Böhler K890, and this is what I expect to see. Just clean, homogeneous alloy. There's no deviation in this at all. And that, when you're talking a powder steel, this is what I'm expecting. It's an absolutely uniform material. And I know there's shortcomings in manufacturing, but the percentage and the instances that I should be able to visually see should be very, very rare. And that's not what I'm seeing with the Crucible Industries materials recently. And that worries me, especially if that's the backbone of my production, that has the ability to impact me or even ruin our business. So this has been a long journey to us becoming a manufacturer. So we've learned so much, and we're doing a really, really good job. And I just need to keep moving in the best direction possible for us and you, so that we can serve you and take the time needed to make these the best possible to provide the best value. And I hope you can just see in this visual demonstration here how damn nice this material is. And that's where we have the higher properties. The more fine-grained and homogeneous these materials are, the better they respond in heat treat, the more reliable they are piece to piece, and the more consistent and accurate the performance characteristics are going to be out in the field. I do believe some of these little issues are the reason that we have random blowouts and things, and just failures that are, I don't know why, they're unexpected and they don't have any apparent reason. But when you have differences in the densities and then sometimes voids, you don't know. And it's like a little time bomb inside your part, and you don't know what's going on in there, and you don't know when it's going to fail and how. And that is terrifying to me. So again, since we're not part of that mass production money marketing machine, I'm here to just throw a little mud in the face of all that. And, hopefully we can get them to improve their standards so that you guys, even on the high volume production level, you're getting more for the dollar you're spending. We need higher standards. These, people say just knives, but it's a sharp thing that you're holding in your hand and doing work with. And I think that manufacturers have a higher burden of responsibility to consumers to do the best job possible. I always go back to that Gerber Parang machete thing, and it seems like the entire product was designed by marketeers. They used an improper grade of stainless steel, improper geometries, put a screw hole in the wrong place, and then ended up recalling over 100,000 units. And it's disgusting to me, the waste of time, resources, people's lives. It's gross. And I don't think that that's a benefit to society, just to be driving this mass consumerism. I want to make things of value that are heirloom quality, that'll last several lifetimes. And that starts with good materials, and I think transparent data, so that we know what to expect, and we have companies willing to be held to those standards consistently without arguing and fighting with us. So I hope this visual representation helps you guys understand the direction we're moving in, but then also the benefits to you of just having the highest quality, most uniform materials available. You get the best tool, and I get to lose less hair. So I hope you found this video to be informative. Man, I'm still sweating through that. So even through that, I probably had a hole in my glove here, but I hope you found this video to be informative and at least fun to watch here. And I guess I'm going to get back to work again now, but stop back soon. We got a lot going on, and there's always lots to share with you. Have a great day, guys. Just taking a look at this void feature here before I continue grinding. It looks like it's about to let loose here. So we definitely have a pocket there with just a little foil on top here. So I'm expecting to break through this now as we continue to finish grinding. So I've now gotten this off the table here, and that foily stuff has come loose enough that I'm able to lift it off the part now. So chunk off of here, lift up some of these other areas to expose a darker void surface under there. This is just a kind of a foily situation on top here. So yeah, still issues there.